Hey guys, glad to see you all. And yeah, this is our meeting after the Connectathon. So we probably should share our status. And I think we can start from Ryan because Ryan did this huge work and shaped everything what we discussed in a spec.
Yeah, sounds good. All right. So basically, I took some effort to transcribe our discussions and try to keep things as faithful as possible. And but of course, there's several places that weren't clear or going forward, so I kind of had to fill in some gaps based on my own interpretation or understanding of the problem space. So I think anything in here is like obviously tentative and subject to change. But I mean, I kind of just to kind of walk through things. Started with some of the high level requirements. Maybe I'll just sort of touch on the high sections, and we can talk about which ones we want to discuss as a group here. And I'm not sure how much folks have had a chance to get to look at this anyway, but just some high level requirements that we touched on. I think that and some breaking down the layers that we kind of identified while we were in New Orleans, between the annotation layer, the underlying representation of FHIR data that should be lossless, the view layer, which is kind of the central focus of everything we're doing, and the analytics layer of building data analysis over the views and whatever tooling users prefer. So then a lot of it, I think kind of the meat of this draft is I took a pass at kind of everything that we showed up and tried to sort of write up a JSON structure documenting all the fields as well as I could. I know that there's already been a couple questions that have popped up with regards to some of the semantics and some additional changes that we made through these. And so I think that'll be a good topic to discuss. Those will be good topics to discuss today. And I tried to kind of define some of the nesting semantics. I know like one particular question is like the need for cross or what options we might have in that space. And also expanding the list of core FHIR path functions. So that could be a good thing to touch on today as well. And then there's some open questions. I think the biggest one is like our date time conversion behavior. So that's probably a good topic to nail down. And then I just kind of added a couple simple examples, but with in this space. But that said, I think that it's kind of worth well, maybe I'll just pause for like any areas that this group would want to zoom in on. I mean, overall, so maybe we can discuss any open areas of ambiguity. I saw others, like saw both Dan and John, and I'm sure others have been exploring like building examples and that sort of thing using this space. So maybe if we land on, we should discuss any open questions, but I definitely encourage the addition of examples to this page because I think that could benefit from it a lot. I mean, the ones I have are very trivial. I think I saw like a blood pressure nesting example, which I thought would be an excellent addition to help understand it. I was probably going to add something like that myself, but I see that there's I think a pretty nice one that I think was it Dan? Was that you? I put that together. Okay, yeah. But yeah, I'll pause there for thoughts or discussion.
Mm-hmm. Yeah, thank you guys. So this is in our GitHub repo, so everybody can go and read it. And I think maybe then you can show the more sophisticated sample of view definition.
So so I just tried to kind of port some of the earlier example I created to the kind of spec that Ryan put together, kind of the compendium of ideas from New Orleans. And there were a couple things that were interesting that came out of this. And so we may want to discuss those more or further. So I guess one of the things I think one of the topics for discussion is around filters, which is currently an array of strings. I put it in as an array of objects, although right now it's only a single string per expression. And I think the logic there was, we have like description elements on name and description on most of the other elements. I think name there is actually used in the variables to refer to them, but description may be helpful for like summarizing what a view does. And so I thought we might want that for filters too, so that we could have kind of a, if we build tooling around it that creates documentation or has a UI or other things, be nice. And then it kind of just also gives us flexibility to experiment with things. If we want to throw a property on filters, it's really easy to do if it's an object to experiment with. Otherwise, whoever does that experiment has to kind of create a different schema. So at least even just for the exploration phase, if we may end up taking it out, I think it might be helpful to have the same structure as we have for variables and columns, where we have just an object for each element, and the only required field would still be expression. But we can discuss that. And then the other two things I noticed that weren't in the spec is we have .exists, but we don't have .empty. And I think data absent reason is kind of a good use case for .empty. The alternative would just be to flatten everything and then filter in the analytic layer, which we could also do if we felt strongly about it. But I think it might be a good FHIR path element to add. And then I think we had .getID in an earlier version of the spec that Ryan had. This is actually one of Ryan's suggestions, which I think is really good. So this completely would abstract the analytic, what are we calling it, annotation layer implementation from the view layer implementation, which I think is a really nice property. So so whether ID is materialized as a pre-parsed kind of reference, or whether it's a hash of something that to allow for data from multiple sources, like the view layer doesn't, or the definition doesn't have to worry about how that's created. All it has to say is get ID, and then the FHIR path implementation will do whatever makes sense for that particular use case. And actually, yeah, and so I kind of did some ugly hacks to Josh's app to get both of these things, well, get of type working, which isn't implemented in the JavaScript FHIR path library for some reason. And then
it is implemented, but you should load the model, what they call model.
Is that the problem?
Yeah.
Okay.
Yeah, and I didn't know what version to load, so I just avoided doing it, but probably loading the R4 models is the right thing.
And that's interesting
cool. Okay.
topic, yeah, because for JSON it's more natural to say value quantity as a one element, yes. But I see that most of examples we like this of type or S stuff.
It's actually not valid FHIR path to say .value quantity.
Hold on.
Okay. So
What?
that's the only way,
Yeah.
to do this.
Yeah, hold on. We
Whoever's
got mute
not on
Arjun.
mute, maybe you could mute. Yeah. So, cool. So we can add that.
Nikolai, can you mute Arjun?
Okay.
I didn't mute it, Arjun. So I think we have two Arjuns. That's why there's an echo. Arjun, can you have only one exemplar of Arjun?
Oh, sorry, I didn't realize I was here. All right, thanks.
Okay. Yeah, so anyway, we can fix that. And then the other thing that was kind of interesting is, so I did create a .getID implementation, again, very hacky, where I'm basically just splitting the reference at the view layer. And so that's, going to be slow, but I think it kind of points to the value of this abstraction, right? Because if I was querying FHIR data that had the IDs pulled out, I could have a different implementation. But if I'm querying, if I'm using kind of FHIR JSON, ND-JSON files that don't have any kind of pre-processing, I can do this as part of the either in this case the FHIR path, or in alternatively in SQL. So this link now works and kind of does what you would expect, right? It creates one line per blood pressure result for blood pressure results that have both a systolic and diastolic value, and extracts the date, which in this case is a date timestamp. I did notice that I think it was for this one in one of the US core examples, they have just the date portion and not a date timestamp. So I think that goes to what you were saying, Ryan, which is that we need to think through how we would handle that sort of situation. And maybe that doesn't come up that much in the real world. I guess unclear whether like some of these values might just have a date. And if you're trying to figure out if that's before or after something, you kind of need to, we might need some ways to work. Anyway, so this is kind of the first of what I hope will be a bunch of real world examples that we could drop into the spec to kind of stress test this, because I think figuring out if there are FHIR path parameters that we're missing or other things early on could be really valuable, or if there's structures. And this is a simple one that doesn't do any sort of cross joins. But I think we need some of those more complicated examples too, to kind of, figure out what makes sense. So yeah, that's what I wanted to show. Happy to discuss more. We could also dig into some of the areas here. And then I know John had also found a few things in his early implementation that may be worth looking at kind of early in the meeting.
I created some much more simple examples, just trying to get my head around the actual basic concepts. And I went through and implemented all this stuff, and it raised some questions for me. So maybe I can sort of bounce my understanding off you and see if we've got to the same place. So I actually wrote a bunch of simple test cases, far from complete, but just sort of starting to explore, and in particular the unnesting stuff, because for me that's the sort of part that's the most sort of open to interpretation. So test case 1 here, I'm just sort of saying this is just use of singular elements with no unnesting. So that's pretty straightforward. I do have like some test data here that shows you what I'm querying off here. So that's uncontroversial. Here I'm unnesting 2 elements that are singular relative to their common parent, which is a repeating element. So for example, you can have multiple names, but you can only have 1 use and 1 family per name. So that's also pretty uncontroversial, I think. Here I've got multiple levels of unnesting that have the same lineage. So, we've got a name, which we've unnested, and then we've got a given name, which is also repeating within the name, and we've also unnested that. And if we do that, then we end up with, and stop me here if I've got anything wrong, but yeah, we end up with a row per given name, basically. So
I'll at least pause you here, John. Did you write in the second variable name.given instead of %name.given intentionally?
Name clash. So what name do you mean in the second expression? Is it name of variable or is it name of the patient name?
Well, it would only be the name of the variable if I put a % in front of it, right?
Right. So at least the way that I interpret this, I would throw an error, because you've told me that you're trying to unnest, but then in fact, instead of unnesting from a previously defined variable, you've started a new expression that will return an array of given names across all names.
Okay, that maybe explains one of the questions I was about to come to. Because what we said was unnest is not possible for things that are not of the same lineage. And what you're saying is that's how you enforce that.
Yes, that was at least what was in my head. Now, we might decide that's a bad idea. I think it's internally consistent, but I don't know if it's, good ergonomics.
Yeah, okay. So anyway, moving right on. The test case 4. So this is when I decided to try something else. And here I actually I tried to unnest 2 things that are not related. And because I haven't taken quite those same assumptions as you, Josh, I went ahead and did this. And what this does is it ends up with effectively a cross join at the resource level between these two things. So this ends up with, you know, each name and also the two different marital status codings that are present in the resource cross-joined between those two. Now, this is not what Ryan put in the spec, because what the spec says is that this should throw an error. And if you want to do this, you should use when many cross. But I couldn't quite figure out exactly the right way to do that, I suppose. And I also couldn't really figure out what it meant if you had like, you know, unnest and cross, or like cross combined with other things. I couldn't quite get my head around that. In my opinion, it can be useful to have cross joining. I just don't know to what extent it's necessary.
John, what other option if not cross join? So just take first, or so you have.
I don't think take first is very useful.
You have two nested arrays, yes. So the only way to flatten on that level is do cross joins, or just say we don't have cross joins at all. Yes, so you could not do this. I think that's the two options. Yes, and as we discussed, having cross joins still may be useful for some, maybe not the primary scenarios, but for some of them. Yeah, Ryan.
Yeah, so I think that there are two scenarios of cross join. I mean, underneath the scenes, they effectively be implemented as cross joins. But the two distinct scenarios, which I think was Josh was kind of alluding to as well, is like if you have cross joins of parent-child relationships, I think those have pretty clear semantics. So if we were to use like a unnest name, then an unnest name.given using the parent variable, then those have pretty clear semantics, and I think that would work as it behaves. This example that's on the screen right now, yeah, so this is like a different category of cross joins where you have two trees that are being cross joined together. Yeah, and it's less obvious how much of a need there is for this for me, and so in this case, I think that we had kind of landed at when we were in New Orleans, we kind of landed, yeah, we should support this, but maybe make it like an explicit decision. So hence the when many cross. It would be the way to make that an explicit, yes, I want to cross join these things. But I totally appreciate and frankly also feel, I think, some of the ambiguity that I think John is describing here. It's like, which one of these do I put cross in to get the semantics that I want? And so, yeah, I wonder if like when many in the cross, the behavior doesn't seem super well defined. So I wonder if that's the right place to put it, or if there's some other ways that we can make cross explicit, like maybe flagging at the resource level or something like that there. But yeah, so I think that this is a great use case to drill into. Yeah, this specific case of cross joining between resources. One, if we should allow it, and two, like how exactly we want to make it explicit.
But Ryan, do you consider like unnesting children as a cross join as well? I think it's not cross join, yeah.
Yeah, it's not. I mean, the semantics now, the SQL underlying SQL may implement it as a cross join, but it's a very special. So from our perspective, from the spec perspective, it is not a cross join.
Okay.
The underlying SQL may use a specific use case of a cross join function, but it's parent-child. So yeah, we need to be precise there as well. But yeah, for our case, like a nesting name and then a nesting name.given using the variable. I would not consider a cross in this setting. The one on the screen I do consider a cross, and I think we need to figure out what the best way. So maybe my question for the group is what would you expect here to if we take John's example, which is great. I mean, how should we express? What should when many say? Should it be cross, or should cross be someplace else?
I kind of think that it's more like, what is the join conditional on? And I think maybe we've got the choice of asking the user to specify, like to say, I want to opt into it being conditional, and this is what it can be conditional on, or to flip it around the other way, and say, in these cases, I want it to be unconditional. Do you know what I mean? So we could either sort of ask them to specify, we could have the default that it is always conditional on on being joined to its parents, or we could have the default as it's going to cross join unless you say otherwise, sort of thing. Or the other variations on that is it errors in certain variations of that. So I guess it depends on the usability, and I guess the cost of being explicit is that, well, you have to be explicit every time, and the cost of not being explicit is that it's kind of a bit more magic. Yeah, so that's just sort of the way I've been thinking. But
well, my preference would be to be explicit. I mean, these views would get defined once and be used many, many hundreds of times theoretically. I think that the hardest part about what we're building for people is going to be understanding this, right? They're going to go through the same thing that you're going through right now, John, where they're trying to use it and they're thinking, that's an interesting behavior. That was unexpected. If you explicitly intonate in the schema file, yes, I expect this to cross join, I think that'll be clear to people who are approaching this for the first time, at the cost of it'll be a few more keyboard strokes, right?
Yeah, but
yeah, as long as we have an intuitive way of saying that, yeah.
So let's say the second unnest, which is not parent child, should be cross. Yes, always. So you can write unnest twice unless it's parent children relationship.
So what do you mean twice? You mean in different variables?
I mean in different variables.
Yeah. So one thing I'm hearing is let's try to be explicit so folks know what joining behavior they're going to get, which seems good. For unnest, there is also this sort of hidden complexity that you could be attaching at any point on up the hierarchy. So like your unnest expression here calls out name.prefix, but it might traverse some paths that introduce more arrays in them, for example. Do we care about trying to distinguish that, or we're just saying as long as there is some point in the previous hierarchy that you can attach to that is lower than the root of the resource itself, that's what counts for considering something to be an unnest?
Yeah, that's a really good point. So what if I just removed the name variable from this, would it actually join up at both name and prefix level? Or would it sort of leave out the condition for joining out the name level and only have the condition for joining up the prefix level?
Right, and that's sort of why, like, maybe it's the same as your suggestion about join conditions. The way that I was thinking about unnest, you would use it with a variable. And so that expression would always start with a %, and that would be your join condition. But maybe there's a better way to make that explicit without forcing people to thread the same variable names throughout.
Now, for me, it's still like SQL model when you list the tables, yes, after from, and they all by default cross join, unless you state it differently, yeah. So for the parent children, if we start from variable, then we expecting this is not cross join.
Yeah, I mean, the default stance we could take is that things cross join unless otherwise specified, right? That could be what we say. And if that's clear to anybody who's approaching this, then maybe we don't need to be redundantly indicating that we're cross joining all the time, right?
Well, the thing is, I think you would almost never, I would say never, want to cross join between two columns that you know have a common, a nearest common ancestor that is closer than the root, if that makes sense. So, I mean, if you take out all this variable stuff and you just wanted name.prefix and name.family, I can't conceive of a situation where you would want to, where you would not want to join up the names.
So you're talking about this prefix idea that we can common prefix, search for the common prefix and decide that this is a join criteria. But we discussed there's some complication when the more complicated expressions are on the way. And I don't
like
think
we talked about some in the chat, for example, like if you're doing an analysis of co-occurrence of components, you want to say, like, in my observations, what pairs of components show up together? I think that essentially looks like a cross join of components. I'm stretching a little bit, sort of fishing for a use case, and I'll be transparent about that. But I mean, it does seem like they're out there.
Yeah, I mean, I agree they're out there, but honestly, I feel like, I mean, I'd stretch to find use cases as well, and so I might make the argument that the use cases, while they do exist, are rare enough that I would defer that to building views on or building layers on top of this. And so you could create, if you needed to cross join two things in observation, you could create separate views of those components and then cross join in the SQL layer on top of it. So it's possible, but avoid this sort of thing. I mean, one path would just be to, basically treat it as anything outside of like a linear parent-child series of if you have multiple unnests, they must be a parent-child collection, which has very clear semantics, and disallow the cross join. And maybe this gets back to like just that sort of flag to make it explicit. I think I'd also be fine with, like, if the default is like a cross join is an error condition, unless we have something like either in the win menu or on the resource that just says, hey, cross is okay, I mean it. And we'll just add documentation that says there be dragons if you use that, because it can lead to some surprising behavior.
Like, do we want to like explicitly specify kind of the parent variable as part of the expression here, or sorry, as part of the, I don't know what we're calling this object here. So instead of saying like when many unnest and then assuming that we're going to put in like if there's a variable, we'll assume that that's the root, and if not, we'll it's ambiguous. I mean, we could say like unnest could be a key, and then we could say unnest from this variable, and that could be like percentage resource, or it could be percentage a name, and then it would be explicit like what level we're unnesting from. And so if I want to cross join, I would kind of not unnest or unnest at the resource level, and if I want to unnest relative to a specific variable, then I can put in the variable. So I guess it's kind of similar to what Josh was saying in terms of like always starting your unnests with a variable, but we could be more explicit about that and just say like, say you're on, where you want to nest from as a component. But that's kind of a half-baked thought. So welcome kind of thoughts about that.
I propose, like, if you nest inside, you do recursive definition, like you start unnesting of name and go inside this variable. Like create the key like a nest and then define something like vars inside the name.
I'm thinking like it would be similar to the logic we've been describing, but just with an explicit unnest root. So if you have two, like, I guess part of the issue is that we can have conditions in a variable, right? So you might have similar roots, but have two versions of them. And so being explicit about, this is, name with a particular use that's being unnested with the use of nickname that's being unnested, and this is a name with a use of something else, use of official that's being unnested, and kind of having those two separate unnest paths, but be able to specify like, this is the unnest path that I want as the root for this particular unnest expression. Probably need to create some examples, but does that make any sense?
I put it in the chat, but just to note here, if we wind up taking a few of these decisions together to support this kind of more explicit unnesting, as Nikolai said, where your sub-expressions go deeper and deeper in the JSON tree, and we put cross joins off the table. If we make both of those decisions, I think we should take a really close look at FQL, because FQL also makes those decisions, and it's a pretty nice, concise language for doing that.
I suggested the nested definitions because that's how I think the SQL will look like for the parent-child join. It's going to be nested. And we can say that everything on the first layer is cross-joined. And if you go deeper, then you do this unnested join. But okay, I will try to shape this idea. I was hoping that I will be able to do some implementation. Yeah, and pretty sure if we will try, like I think John tried and have a lot of questions. And John, in your
I
case,
mean, like,
are you generating SQL or are you just using built-in FHIR for Spark SQL?
I'm generating a Spark query, which is analogous to SQL. But yeah, I as a principle, I think I agree with Ryan that this needs to be simpler. It needs to be dead simple, and it needs to be intuitive. I don't think we're quite there yet. And even if it's not that powerful, you can always break out, you know, to separate views and that sort of thing. And I think that would be preferable to sort of having something that you need to be some sort of hero to understand. But it's obviously really hard to make things simple. So I think we just need to do a few more iterations. Maybe while I'm on this screen, I'll also just raise a couple more things to chew on. I've got an array of all the given names for each resource. Inside here, really, there's actually these two names belong to one name and the other belongs to another name, but I've flattened them out, which kind of made sense to me. But if I took that from like the raw sort of parquet representation, if you like, there would actually be a nested array in here, but I thought it would be right to flatten that out here. So that's one assumption I made.
But the flattening is dictated by FHIR, no?
Yes, I think, yes, yep. Because it's just a collection of things.
In this example, did you intend to define a variable called name?
I think it just missed typing.
Yeah, I think that's just a typo there.
Oh, you didn't intend to have a variable, you just intended to go down to the name.given. So yeah,
I think that's supposed to be like that.
I see. So yeah, I find this to be a very surprising result then, just because I would evaluate that as a FHIR path expression in my head and get one array out. But if you had done exactly as you had it before and introduced a variable as the first entry of the vars array that said, hey, I want a variable called %name, which is the name element, then I think that would line up.
I think my implementation is not as explicit as yours. But yeah, so
that's a feature of the FHIR path. Yes, so FHIR path doing flattening all the way. So there is no way.
Yeah, no, agreed on that.
FHIR path. Yes, and I think if we go with FHIR path and not gonna change the semantic of FHIR path, I think that's the answer. Like only one level.
Yeah, I think Josh was just talking about the fact that I haven't specified two variables here for two levels of repeating elements.
Exactly. Yeah, I was just saying if you have only one expression, I would expect that to resolve to only one collection.
Yeah, and here I've got an unnest and an array. So Is that surprising to anybody?
No, it is not.
But here I've got 2 levels of array. Now, not sure what you would think that would be meant to mean, but in this case, I've actually manifested that as a multidimensional array. I don't know if that should be legal or if that should be intended or what.
I mean, in this case, I wouldn't expect, I mean, the FHIR path semantics, I believe, is like, it wouldn't be nested arrays. I mean, basically all the contents of arrays would be, because the FHIR path expression always returns a collection. And so like if you had name and then nested, it would just be like, on these items, they wouldn't be nested arrays. They'd be the same content if I remember the resources, but be just one array for each row.
I don't think it's common to kind of to provide to FHIR path engine the array of something, but I would suggest that the logic FHIR path flatten this array as well. So there is no way in FHIR path to get like array of arrays. Maybe that's the problem, but I don't know. But the FHIR path has the roots in XML, so yeah.
Yeah, you're probably right. So the other, sorry, I'm trying not to monopolize this, but the other thing I thought about was sort of materializable types, which I don't think we've talked about much. But if you have like a column and and it evaluates to something that you can't really put out in a view, like a backbone element or like maybe it's like a complex type, like a coding or a quantity. Do we want to have sort of a set of types that we insist that your expressions evaluate to, that can be reliably rendered out into the view?
Yeah, so I think that by default, we were inclined to be a bit flexible in that space. So folks could be, I mean, just could build views and do some exploration of data. So, I mean, if it returned, I mean, if you have even, just like a high level type that returns a complex structure, it'd be nice to have a view just so you can run it and see what that output looks like, and then drill down from there. And then it's up to like the view runner implementations to determine whether they will accept views that allow repeated or that return data structures and how they would handle with that. So yeah, I think that by default, like we would be views could define it just to support exploratory use cases, but it would be a best practice if you want to create a view that's like used in a more conventional database to flatten everything to basically scalar types.
I think we discussed the mode attribute, which can be CSV and if in CSV mode there's going to be error if you're returning the complex type, but in a default mode it's probably not an error.
Yeah. So were we thinking mode would actually be defined on the view itself?
Yeah.
Well, so I think we talked about this a little bit and landed on it, defining it in the runner, because like the same view might be fine in a runner that can kind of handle showing nested data structures as results, but may fail, like in Nikolai's example of CSV. But I don't necessarily want to have a different table definition for those two use cases. I might just want to be able to pull in a table definition and it'll work in some runners, and then other runners will error. So I don't know, at least in my view, putting it in the view kind of maybe feels like the wrong layer of abstraction.
Yeah, that's kind of my inclination as well. So I guess to answer John's specific question, yeah, like we would be, from a view perspective, yeah, you could return an arbitrarily complex type. From a runner perspective, yeah, it might look at the definition for that, and my CSV runner may say, oh, I can't use this view. It doesn't narrow things down to a flat state.
Yeah, but as long as you're sort of happy with the fact that if a certain runner does render that, like say it's a structure, the way that structure is structured could vary just depending on how that backend has actually represented that, say, backbone element. I mean, there could be variations in the way that they have represented that in the underlying data. And I guess there wouldn't be any sort of standardization around that unless we said something about it, I guess.
Yeah, I guess like maybe the recommendation would be to, if you're returning a structure, to actually, return like a JSON structure per the FHIR spec for whatever that backbone element or anything is. That I think that's that would be like the least surprising behavior. But again, I don't know if we need to specify that much at this level, or leave it to the runners to kind of produce what structure kind of makes sense for them. Because I think the use of these of expressions returning not returning structures, I think will be more narrowly scoped to sort of interactive exploration, or maybe some specialized use cases. Whereas it's like, imagine like most runners and once you deploy a production system will fully flatten it, so this won't be a problem. So I guess it's like a question. I'm inclined not to over specify that at this point, and kind of defer that to the runners until we have like unless there's a compelling reason not to, and we can always identify that compelling reason as we work through this.
Yeah, I think it goes a little bit to philosophy, like, do we sort of have a really tight subset of behavior and force implementations to stick to that, or do we let implementations have a richer set of functionality, but then you run the risk of, if you author, say, something with pathling and you can do all this fancy stuff with it, that it will let you, but then when you go to use it with something else, that might not work because it hasn't implemented all the FHIR path functions, or it doesn't let you render out things that you could with the other engine and all that sort of stuff.
Yeah, and so that's fair. And maybe it's worth, maybe one area that we could define is like common, just like a baseline of broadly supported semantics. So like, in the spec right now, we have a list of like core FHIR path functions. And so we could say, hey, in order to, be like a common runner, you have to support these FHIR path expressions. You have to support CSV style views of all the types. And so that's the requirement for like any runner, but then other runners can do fancier things on top of that if they need to. So it's like support like output of complex structs. I could see that.
It feels a little bit like maybe we start with the simple case and then kind of expand over time, and maybe the same way with FHIR path expressions, although I've been contributing to expansion there, so I feel a little bad. But I kind of think like, certainly like you could do some math, you could do other things that might be useful for some views, but also feel like, maybe we leave those out of scope initially and then see if people are like, if that's a kind of an area that's causing pain and is kind of creating extra SQL layers that aren't really needed, and then pull stuff in. And I wonder if we could do the same thing around types, like start with assuming a fully flat structure except for kind of interactive exploration. And then if folks have use cases where they need like tables with nested JSON or nested structs that they want to then interrogate at the analytic layer, then maybe we push some of that back into the spec. And so kind of leave it as ad hoc behavior where every system will support, or systems runners that want to support sort of intermediate data views for debugging and stuff can do it, but like the spec itself kind of expects a fully flattened view or these kind of arrays. Or if you do the arrays, like it's maybe something that's not super portable. Anything beyond string arrays, I guess. Arrays of structs.
Yeah, I think you can do more on implementation side, as John, the only guy who tried to do this. So after that, we can kind of make some demos and maybe do Q&A session, not only with the people from this group, so then collect the feedback and get back. Yes, so we can highlight these parts we are not sure about, and then just to show to other people and see how they like make experiment, UX experiment.
I wonder if we want to try to get somebody for FQL for the next thing. Sorry, guys.
Yeah, that sounds like a good idea.
I guess as we're still exploring the nesting problem space, which is going to never die. Maybe to Josh's suggestion, maybe we try to get a FHIR person to show off FQL, just so that we have a sense of kind of at least how they tackled some of these issues.
Maybe he will join us next meeting and discuss and show us what they have in FQL, what decisions.
Yeah, Alexander Zotke
Mhm.
I'm butchering his last name, I'm sure, but Alex worked on FQL a lot. He's very familiar with it. I'm sure he'd be willing to talk us through how it works.
I don't know, that might be a good step as we, in addition to implementation, as we start to think through some of the unnesting things, particularly things John brought up.
Yeah, so that sounds like some good next steps. We're about at time. I guess one maybe area of interest, I mean, that we can make, down this thread is like, so I think Dan had some pragmatic suggestions for changes to the spec in terms of like the expression structure, the exists and the get ID and that sort of thing. I mean, I think those make sense to me. So if unless there's objections, I mean, I think that it makes sense to incorporate it. So I guess I'll ask if there are objections or concern, we can discuss it on the Zulip. If not, I mean, I'd say Dan, if you want to put together a pull request with that stuff, then yeah, I'd be happy to do it.
One mechanics question, like maybe we pull the examples into a directory of examples, because I just worry about that getting very large in the spec, but I'm happy to do it either way. I just think I'd like to see a lot of examples. So
yeah, I was thinking that examples can be shaped like test cases. So we can provide like ND.json as an input and CSV as an output, yes, and probably some description. So then we can create like a folder with examples, the input, and maybe input can be shared. That's what we can discuss. And the CSV is output, so people can use it as a test suite as well while implementation.
I like it.
Yeah, sounds good. And I don't mind like a handful of illustrative examples.
Oh, yeah,
So, I honestly do think the observation when you put the blood pressure actually would be good as an illustrative example. So I think I'd love to be. I actually would like that in the markdown, but we should also like start building. We could add it as well to the JSON and start building out more examples there. Because yeah, we should probably limit the number of examples in the documentation to a handful.
Sounds good. Yeah, that's why I was bringing that up. Just see if we want to. I'm happy to put it in, but so we could do that with that one.
Okay, sounds good. There was like a couple questions at the time. Guess in the chat.
Craig, can you tell what you mean by update semantics? Do you consider these flat tables still kind of?
But this LLC was made last year.
So all I'm saying is that this problem of unnest of how to deal with transforming nested JSON structures into flat columns is not a new problem. I mean, this has been dealt with millions of times in different people's code, from ETL pipelines to people needing to transform JSON into Excel columns. Like I've seen this hundreds of times. So I know I've seen some pretty serious projects that have that are a little bit like this, where you have kind of a mapping layer that transforms one data structure into another data structure. And there's YAML configurations I've seen. Obviously, if you were just doing this the naive way, you would just pull your JSON or your initial FHIR into memory and do whatever you want, and then output some data structure, right? So all I'm saying is that this has been looked at many, many times. So I'm wondering if there's any projects we could find that could give us some inspiration on how they do it. And I'm sure, there's probably some specification out there that talks about every single one of these issues with cross joins and when not to cross join, and arrays within arrays, and all these things that we're talking about. So, and yeah, I was just wondering if anybody's ever heard of a project like that as well.
Yeah, I think the challenge is not so much unnesting stuff. It's creating a generalized mechanism for doing so in a way that the user can specify how it can be done in a way that generalizes across all the foreseeable use cases. But my instinct is that we should basically keep this a dead simple method of projection, like in the first instance, and opt out of complicated stuff and basically make that the first cut. And I think we have to do unnesting, but maybe not much more than that, and basically enforce simplicity to a certain extent, because I think that the first cut of this needs to be really simple.
I mean, simple is great, and I love to start simple, But if you start so simple that you can't then do the complex things that are practical and that you need to do, then there's no point in simple. So at least in my opinion, like, you know, if we build this really, you know, nice spec, we put it out there, and then someone's like, oh, I have this use case. Oh, well, we don't support that. And then we start to see that that use case is actually pretty popular. Then, you know, so it's always a balance. I'm not trying to say we should over-engineer.
Actually want people to implement complicated things in this layer. You know, we want to have a way of projecting out and flattening FHIR, and then do all the complicated stuff in your own logic. If I think it's bad if we inadvertently implement something a bit too powerful and then people start putting all sorts of complicated logic in this view layer. I think that would be actually not the goal here.
Yeah. So in other words, it's complex use cases would be possible, but they would be done at a higher layer.
But it's still trade-off. I mean, so I think we should check that everything is implementable. So this is the first goal, yes. So at least what we specified is potentially implementable, and yeah, we have like 3-4 implementation which potentially can check. And then the UX, yes. So that the UX, so I think we should separate this stuff, because yeah, make it too simple but useless, this is one risk. Make it not implementable, this is another risk, but we can check through our, at least through our like 4 implementations, yes. Or maybe we will have more. I'm still in the middle, so I would, even if user may be confused, but you provide this feature, for me, it's better than just skip it and user would not be able to do this. Because you guys keep in mind your implementation, but yeah, but I'm not sure that we all keep the potential use cases for that. If it's, let's say, indeed JSON file translation on fly in S3, yes, without any Spark SQL or something like this, then it may be much more painful. So you can join in your implementation. That's easy. Yes, you can push it on a layer 3, but for other guys, it may be not. If you say, let's say you flattening and then load into Power BI or something like this, like Snowflake, yes. But yeah, that may work. Okay. But I mean, there's a lot of use cases. So let's try to make it implementable as it clear and clear as possible. Yeah. Thank you, everybody. Yeah. See you next week.
Thank you. See ya.